I'm going to talk about degrees, radians, and arc lengths. All right, first, degrees and radians. Degrees and radians are units used to measure the sizes of angles. Let me list some angle measurements in degrees and show you the equivalent angle measurement in radians. Okay? How about we'll do 1 degree, 45 degrees, 90 degrees, 180 degrees, and 360 degrees. All right? So 1 degree is equal to pi over 180 radians. Radians are typically denoted by the abbreviation RAD. 45 degrees is equal to pi over 4 radians. 90 degrees is equal to pi over 2 radians. 180 degrees is equal to pi radians. And 360 degrees is equal to 2 pi radians. Notice that all the numbers on the left side multiplied by pi over 180 give the numbers on the right side. So pi over 180 is the conversion factor to convert from degrees to radians. Notice all the numbers on the right side multiplied by 180 over pi give you the numbers on the left side. So 180 over pi is the conversion factor to go from radians to degrees. Okay? Let me do 2 examples. So 20 degrees is equal to how many radians? Well, let's do 20 times pi over 180, and that gives gives pi over 9 after some simplification. So 20 degrees is equal to pi over 9 radians. All right? What about pi over 6 radians? How many degrees is that equal to? Well, let's take pi over 6. Let's multiply by 180 over pi, and after some simplification, you'll get 30. So pi over 6 radians is equal to 30 degrees. Okay? Now let's talk about the relative sizes of 1 degree and 1 radian. If you chop up a pizza into 360 identical slices, then you'll have some very tiny pizza slices. The little angles associated with each of those pizza slices is the size of a single degree. Okay? How much is a radian? Well, 1 radian is a lot bigger than 1 degree. 1 radian is a little less than 60 degrees. Okay? Let me let you do some conversion exercises now for practice. So, can you tell me how many radians are equal to 40 degrees? Can you tell me how many degrees are equal to pi over 10 radians? All right, pause the video and try those now. All right, I'll go ahead and do these myself. So 40 times pi over 180 gives what? Gives 4 pi over 18, 2 pi over 9. I think that's as good as we're going to get. So 40 degrees is 2 pi over 9 radians. All right. Now, for pi over 10, let's multiply that by 180 over pi. The pi's cancel, and we get 18 after some simplification. So pi over 10 radians is equal to 18 degrees. All right, let's close by talking about arcs and arc lengths. So an arc is a piece of a circle. It could be the entire circle. In that case, it would also be the circumference. Okay? I want to give you now a formula to find the length of an arc, or the arc length. So if you wanted to find the length of this arc, which I've colored in red, it would help to know the radius of the associated circle, let's call it r, and also the central angle associated with that arc in that circle. Let's denote it by the Greek letter theta. Traditionally, Greek letters are used to denote angle measures. The Greek letter theta looks like a capital letter O with a line through it. All right, and let's denote the arc length by the letter S. And I'll put a little line through my S so it doesn't get confused with the number 5. So the formula that you want to remember is that the arc length is the product of the radius and the central angle. All right, with one caveat. Okay, that angle must be in radians. Okay, if it's in degrees, you're going to have to convert to radians first. All right? Now, why does this formula work? Why does it hold true? Okay? Would you agree that if the angle was, if theta was 90 degrees, then the arc would be associated with a fourth of the circumference? Would you agree that if the angle was 180 degrees, that the arc length would be associated with half the circumference? So the fraction of the entire circle associated with theta is equivalent to the fraction of the circumference associated with the arc length. Okay, that was a mouthful, so let me just write it down and maybe you can think about it and it'll come to you. So the fraction of the entire circle associated with theta. Well, the entire circle is associated with 2 pi radians. All right? So theta over 2 pi is the fraction of the entire circle associated with that angle. Okay? And I'm saying that that's equal to the arc length divided by the circumference. And the circumference we hopefully know is 2 pi r. Okay, so both of those fractions are equal. Now simplify. So multiply both sides by 2 pi, so you get theta is equal to s over r. And now if you cross multiply, you arrive back at the original formula in the red box. Okay? All right, so let's do some practice problems and then we'll close. So what is the arc length of an arc on a circle with a radius of 5 centimeters and a central angle of, let's say, 50 degrees? All right, I'll do that one first to get us started. So the radius is 5 centimeters. The angle is 50 degrees. Let's go ahead and convert that to radians. So times pi over 180. So that reduces to 5 pi over 18 radians. All right, so the arc length is 5 times the radian measure. So 25 pi over 18 centimeters. Okay? Let me repeat. The arc length is the product of the radius and the central angle measure in radians. All right, now let me let you try one. What is the arc length of an arc on a circle with a radius of 10 miles and a central angle of 100 degrees? Okay, try that one. All right, I'll go ahead and work it out. So we know the formula is that the arc length is the product of the radius and the angle measure in radians. So 10 miles is the radius, and let's convert 100 degrees to radians. So we'll multiply 100 by pi over 180. And then there we go. So that's what we want to simplify. So this is going to be 1,000 pi over 180. Or, let's see, 100 pi over 18, or 50 pi over 9. I don't think I could do anything else besides that. So 50 pi over 9 miles is my final answer. And I hope that was your final answer as well.